Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to take a look at not one Vic-20 motherboard that doesn't work, but two, and I'm going to repair both of these. So without further ado, let's get right to it. Alright, here is the first Vic-20 sent in by viewer Brad. I wrote black screen, unknown. I mean, not very helpful diagnostics there. Now, as you can see, this is a later Vic-20 board, the cost-reduced version. I think it's called Vic-20 CR. Smaller form factor. This actually uses the regular Commodore 64 power supply as opposed to a DC input, or rather an AC input, which then has a large linear voltage regulator on the motherboard here with the giant heatsink. Gets really hot. This, of course, uses 5 volts DC from the external power supply, which makes the machine run a lot cooler. What I need to make sure before we do any further troubleshooting, I have the video cable here. I'm just going to grab another Vic-20 just to make sure that my system here is working properly. Actually, the Vic-20 that I have handy is the type that requires the AC input, so I'm going to use the ZIF64 here for testing. I always recommend you do this. Just double check your power supply is working properly and your video subsystem. If you're using a monitor, it's a lot easier. You don't have to worry so much because you can kind of tell if the monitor's on or not. But with my video capture setup that I have here with the RetroTink and all this stuff, it doesn't always work properly. So I always like to test it first. And there it is. Okay, well, we have the wrong setting on the RetroTink, which is easily fixed by just pushing the buttons. So now we have confirmed a good video signal. So let's go back to the Vic-20 board. All right, so plug this in, make sure the power's off, and it is. Okie dokie. We turn this on. Now the RetroTink does go black, so we're definitely getting a black screen. So there is some kind of a video signal being output from this machine. But clearly something's not working on this thing. So what are the first things we need to do when we have a machine like this with a black screen? Well, I'm going to bring up the oscilloscope, and here it is. I was just doing a probe compensation on the virtual bench. So there it is. First thing let's check out that we're getting 5 volts. I think I already did this before. 4.94 volts. If I turn the power switch off, it should drop and go back. Yep, so we know that it's getting a good 5 volts from my external power supply. All right, next up we got to get to the schematics. So we're going to be looking for the CR version. I see here on Zimmers there's Rev D, which I assume is this thing. I don't see any kind of like part number on here. So let's just go with this NTSC new design here. Unfortunately, these pictures have not been joined together. So let's just open all of them in tabs. Okay, so here we are on the first one, and what I want to see is the CPU, because what do we need to check on a CPU to make sure a computer is working? Well, we need to have a good clock, and we have to have a good reset signal, where to verify that the power is good. The 6502 has a clock input here, which is phase 0, and then it has an output phase 1 and another output phase 2. So let's check out that pin 37 has a good clock. All right, there is the clock signal. Now it's just jumbled up, so I'm going to use the scroll wheel to zoom right in. Right down here, we have a frequency of 1.02 megahertz, which is perfect. Now, if you don't have a fancy oscilloscope like this virtual bench, I've recently put out a couple videos where I reviewed a $60 scope, a USB type, and another one that was $120 or $125 or so. That was a handheld 2-channel scope, and both of those would work perfect for all this work that I'm about to do here. Okay, we verified that pin 37 has a good clock signal. Let's check out these 2 outputs here. These do need to work for the entire system to work. And if the 6502 is bad for some reason, maybe it's not outputting good clock signals on these 2 pins. And so the first output is on pin 3, and it looks good. It's 1.02 megahertz. It's always going to be the same exact frequency. It's just the phase is shifted a little bit. So it's got to look like a good square wave, and it does. And I think the other one is on 39. And there it is, and that looks perfect as well. So we know the clocks, at least around the CPU, are working fine. All right, next up is pin 40 right here. That is the reset signal going into the CPU. Definitely, if that circuit's not working, it's not gonna work. I have to wonder if I've ever actually found a machine that didn't have a good reset signal. I'm not sure that ever actually came up. Okay, so that took a long time to come out a reset. So it's reset low. So see how it was low when I turned the power on? Let's do that again. I think there might be a problem with the circuit, but that's, wait, am I not on this pin properly? Let's just double check here. Okay, maybe I wasn't making good contact. Let's try this again. That takes a long time for the reset to terminate. Look at that. It's like 2 seconds. But I don't think that's a problem. I mean, it's just gonna take the computer longer to boot up. But it's definitely high right now, which means that the reset is released the CPU and it should be executing code right now. So let's take a look at the Vic-20 schematics here on this board to see what's going on. So the data lines right here, there's 0 through 7, they just go right over to this LS245. And I know I've had a machine before, I think it's this chip right here that was bad. And basically that chip had failed and that prevented the machine from working. So we need to double check that the data lines on the CPU here are looking correct. And then we should check the other side of the LS245, which it says is UF8. Yep, UF8, that's this chip right here. So let's check both sides of this that we have good signals. So we'll be looking at the CPU pin 26 through 33. All right, there is the first one. That's looking weird. Huh. I'm confused at what happens when I turn on the computer. We see activity. Let me zoom out a little bit. What are these weird pulses here? So we turn it on. Okay, that time it didn't do anything. But one of the times it looked like it was busy doing stuff right off the bat. Seemingly activity while the CPU is in reset. Because remember, there's the reset line and it's high right now, which means the CPU is not reset. It's reset when it's low. And notice how long it sits there and reset. So why is the CPU doing nothing right now? And when we turn this on, well, seemingly nothing. But there's activity there. That's while it's in reset. That doesn't make sense. Let's go through all these other pins here and just see what we see. That's a little bit more like I would expect. It's low. The little dips that I'm seeing there, that just doesn't quite look right. I don't know, weird. So this line here, when we turn it on, okay, there's activity, and then it goes away as soon as the CPU comes out of reset. It's so strange. Well, looking at all the lines, this CPU is definitely not doing anything right now. It's clearly not executing any code. Let's take a look at the address lines. These are the address lines 9 through 25 with a little break around the bottom. Pin 21 is skipped. All right, so here we are on pin 9. That's one of the address lines. We turn the CPU on, nothing, and then it just goes high. Now, when the computer is trying to boot, when a 68000 is trying to boot, it goes all the way to the top of memory. It's like up in FFF something or other, and that's where it tries to start to execute code. I don't understand what's going on. Do you see that? I turned the computer on and there was activity there. That just makes no sense. That should not be happening. I'm just gonna swap out the CPU proactively here. In fact, why don't we pop it out of the computer and take a look at those pins? So that's the CPU removed. Let's look at that data bus pin that we kept seeing activity on as soon as I turned the computer on. Maybe something is causing that. Like, I don't know if the Vic, which is pretty warm, maybe that accesses memory and that causes activity on the data bus. I'm not exactly sure. I'm not super familiar with troubleshooting Vic-20s. Okay, so I'm on one of the data bus lines. If we turn it on, yeah, we just see no activity, which is what I would expect. Because right now we are on the side of this LS245 that only the CPU is on, and maybe the ROMs are on. I don't remember if these are there or not, but this is somewhat isolated. So whatever the Vic is doing shouldn't be visible on this. So I really feel like it's the CPU that's trying to do something while it should be reset. And yeah, basically all these lines, nothing happening at all. All right, so I'm gonna grab another CPU. Let's see if that changes anything. Here is a Signetics 6502. Looks like it's from 1978 maybe. It's a pretty old part. So it's definitely older than this machine here. Now, while MOS chips makes some unreliable chips like the PLA on the Commodore 64, definitely feels like the 6502 is a really reliable IC. Just grabbing some Deoxit here. Deoxit that socket. You know, I had to say it at least once in a video, right? But yeah, the 6502 is pretty reliable. So is the 6510, like the processor that's in the 64. It just generally doesn't cause an issue. So let's go on to one of these lines again here. Look, we're seeing that same activity, but notice we still have activity, so it hasn't just stopped. Doesn't look super good, but let's take a look at the video. Look, we actually have a screen. It's not quite working, but it's working better. Yeah, look. All right, so we're getting something. So it's actually initializing the video chip here. All right, well, it's kind of glitching out though. You see that? That's actually not coming from the cables or anything. That's just something happening here. Now remember, Brad sent in these machines and he mixed and matched to find a working Vic-20, so we don't even know the state of these ICs. But all right, so I'm not gonna rule out the 6502 here immediately, even though this seems to work a bit better with this Signetics one in here. Could be that the bus transceiver is faulty in here and this has stronger drives and it can push through that, or I don't know, you know, whatever. It's not a sure thing that that CPU is bad. I wanna make sure that these ROMs are in the correct spots. I don't remember if this had it in there and I just populated these. So I just did a quick Google and this is the character ROM, this is the basic ROM, and that's the kernel ROM, and these are in the correct spots. I'm pretty sure I verified that these worked in the Retro Chip Tester Pro, but just to double check, I'm gonna grab that. Actually, before I do any testing with this, why don't we see what happens on this machine when we pull out one of these ROM chips. Let's take out the kernel ROM, just see what that does exactly. Okay, we turn on the computer and we're literally getting nothing now. All right, looks like I had some deoxit already in these sockets. So let's pop that back in, see if we get the blue screen now. Okay, we're still getting it, whatever, it's a cyan screen. This has me thinking that what if the character ROM is well, no, you know, what if the basic ROM is bad here? We take this out and we turn the computer on, what are we gonna get? Okay, we get the exact same screen here. Kernel ROM out, we get nothing. But with the basic ROM out, we're still getting the same thing. Let's take out this character ROM. I don't think this is gonna do anything because right now it's not trying to display any characters. It doesn't look like it's trying to display characters. So I don't think taking this out is gonna cause any change. If it's trying to display characters and you take this out, you're gonna see probably garbage or, you know, weird stuff on the screen. Okay, no change as well. Okay, so I have check marks on these chips here. Well, not that one, but there's a check mark on there. Well, I also see, oh, that's a K that I drew. And that one looks like it's a check mark as well. But just in case, I have a couple others here. So I'm just gonna try this in here. Let's just see if that changes anything. I'm not thinking that this will. Nope, exactly the same. And we'll switch out the kernel as well. All right, and what does that do? I'm sure it's gonna do nothing. No, it's just the same green screen. I'll pop in the character ROM again. Character ROM back in. So I think the ROM chips I just took out of here are fine. I'm gonna leave these ones in here though. Look, we're still getting that weird flashing. You know, I am partially suspecting, wow, you know, there's all sorts of things that could be the problem. I think for a troubleshooting perspective, let's take out these two I/O chips here. It's like the keyboard and user port chips here. So these can definitely trash the bus, keep it from working, and they're not necessary for the computer to boot. It's kind of like on the 64, you can take out the 6526 chips and the machine will still work. So let's see if that changes anything. Nope, no change. All right, let's get this video chip out of here. And I have a spare one right here. It's a 6560-101. Looks like I've already deoxited this socket here. Let's see if that changes anything. Looks like we're getting a black screen with this one. It's actually worse than this one. Interesting. So I'm gonna go back to the one that at least seems to produce a video output of some kind. All right, there we are with the cyan screen. So I know this chip swapping here isn't like the best diagnostics in the world, but to be honest, when you have socketed chips, and I'm pretty sure they're socketed on all of these, you may as well swap and double check that they have good firm connections before you start figuring out that, you know, some of these other ICs might be the problem. Now I'm gonna try a cartridge because like the PLA on the 64, this doesn't have a PLA, but there is chip select logic here. And what if some of that is not working properly? maybe a cartridge will work while the machine doesn't boot into BASIC. It's worth a try. I don't think it's gonna work. Okay, well, it's different. We saw a yellow screen that then changed to cyan. Let's see if that's repeatable. Yep. How interesting is that? So that kind of is telling me, I'm gonna grab a different cartridge. I have a couple here. This was Radon Fort Knox. I'm gonna grab another one, and I'm gonna see if that changes the way it looks. Oh, these are so hard to get out. This is ridiculous. All the Vic-20s are impossible to get the cartridge in and out of. They grip it so tightly. I wanna see if it does something different with a different cartridge. And if it does, that could imply that this thing is running code, but there's something wrong with the video chip. And I guess I should hook up the speakers because maybe there's some sound. Here is a copy of Radar Rat Race. Terrible music, game I used to have as a kid, which I used to play and thought was, you know, fun, but, you know, really wasn't. All right, what does this do? Oh, we're getting a blue screen. Okay, I'm gonna hook up a keyboard to this thing. Let's plug in a keyboard. I'll use the one from the ZIF 64. Oh, look, those pins are shorted together right here on the keyboard connector. I think someone mentioned that in my video on this motherboard originally. Don't think that will cause any kind of problem. Like, it won't prevent the machine from working. In fact, I can't use the keyboard without plugging these chips back in, right? 6526s aren't gonna work. I think that's the one that's required for the keyboard to work. Yeah, the keyboard pins here on the 64 and the VIC-20, they're just scanned by the I/O chips. So when they're shorted together, it's not gonna cause a problem. You have to think about what you do when you push keys on the keyboard. It actually shorts the pins together, basically. It's just how it works. All right, turn this on. Let me grab a speaker connection. Hey, we have no video now. What happened? Did I plug something in wrong? That's in the right way. That's still in. That is curious. Now we're getting a black screen again. Just when I thought I was making some progress, I'm making no progress again. I'm gonna pull this chip out of here. Uh-oh, I see what I did. I bent some of these pins over. Look at that. Whoops. See if that goes back to the blue screen. Okay, we're getting the blue screen. I think it was not happy with these pins bent over here. They weren't shorting or anything. That's why I like to use Deoxit on these sockets. It just makes the insertion of the ICs so much easier, and you're less likely to bend pins. These old oxidized sockets, they're very stiff. And if you're not completely careful, you can cause that problem, which I just caused. Okay, here we go. That should still work. Blue screen. Yep, there we go. Let's get the keyboard hooked up again. Alrighty, I have an audio cable here to plug into the sound. And the reason why, I think when I start this game up and I hit F1, I think it starts the gameplay. Okay. Maybe, maybe not. Does this need a joystick? I'm gonna try a joystick though. See if that does anything. That does nothing. Okay, so the computer is sort of running, but not fully. Oh, you know what? I just had a thought. Maybe I need to put both of these back in. I don't actually know on the VIC-20 which one is for the user port, which one is for the keyboard. Look at that. Did you hear that? It's freaking working. There's sound. The music is going. Here's the bad music. All right. All right. So what does this tell us? This VIC-20 is working right now. At least it's executing code. So that definitely confirms that this CPU, I think, is bad. I'm still not going to rule it out immediately, but I'm going to draw a question mark on it, like so. Okay. Now, this video chip, this is where my suspects are with this video chip. There still could be a problem with the way it talks to RAM. Let's go look at the schematics. I have another one of these chips, but I don't have it handy. I just have this one we tried that didn't work at all. So let's take a look on here. I want to see how it talks to the RAM. This has got to be the VIC right here, right? So here's the VIC chip, and there's the data bus line 0 through 7, and it's BD, so it's like a shared data bus. So it goes off there to page 3. Let's see where BD is coming from. Let's go back to the first one here. Okay, so right here. So this is buffered data bus right there. So this is the 74 LS245, this one right here, which I suspected might be bad, but I don't think it is. So this buffers the data bus lines from the CPU through this and then to the rest of the computer, and that's the BD 0 through 7 here. Also, there are address lines here, VA 0 through 13, I guess. I have a feeling those are probably used by the VIC, hence the VA part right there. And here's the VIC again. Yeah, I see VA 0 through 13. So VA for video. And I think the address lines talk to the rest of the chips directly off the CPU. But the buffers, which I think are these two right here, buffer the address lines that go to the VIC chip because it needs to also be able to talk to the RAM. So I have a feeling the RAM is going to be hanging off of the VA lines as well. Unfortunately, I have to figure out like where these lines are going because they're cut off on the scan. It's not that one. It's not that one. I think it's this one right here. Okay, there it is. Yep, C214. This is the SRAM chips here. The RAM on the VIC-20 are these two and these SRAM chips. So these VA lines are definitely shared between the VIC-2 and the RAM. Now, that tells us quite a bit. If there was a problem with these buffer chips, for instance, like they weren't buffering the address lines properly, then the RAM wouldn't work and the machine wouldn't work at all. Those have to work for the CPU to be able to talk to the RAM. And we know it's executing code. It's probably booting into BASIC. And it's obviously running the game there because we heard the sound and everything. So we know that's working. All right, here's some spares sent in from a viewer. Don't remember your name, but thank you very much. We have some CPUs on here. We have lots of ROM chips, and we have tested working video chips. 6560s. All righty, well, let's pop this one in. It's got a check mark on it. Let's see if that does the trick. Look at that. We have a working VIC-20. Oh boy. All right, so if I pop out this cartridge, we should at least get, the basic screen. And we do. It works. Freaking works. The image looks quite good as well. There's some pots here for adjusting that stuff. Before I do that though, I am going to draw an X on this VIC chip, which we know is bad. And let's also pop in this other VIC chip here. Let's double check that one now that we have this machine working. All right, this was the one from the other motherboard. Brad sent in 2 VIC-20s. That chip just does absolutely nothing. So this chip is also bad. So 2 bad VIC-2 chips, or VIC chips, not VIC-2, VIC-1 chips, the original VIC chips. Bam. All right, so we pop the known good VIC back in, double check, we get to basic. We do. While we're at it, let's go back to the original CPU. I wanna see if this thing, which I draw a question mark on, is a problem. No pins are bent, notch at the right side. Don't wanna bend those pins like I did on the I/O chip there. Okay, power up. Nothing. Another dead chip. Very, very strange to have a bad 6502. Big old bad chip. Look at that. I'll grab one of these 6502s that I had on my spare parts board here. So this originally would have come out of a VIC-20. These were all salvaged out of a VIC-20. I don't know what happened to the rest of the machines. So that kind of begs the question, that other VIC-20 board that Brad sent in, let me grab it because it may only have similar problems as in a bad video chip. First, I'm just gonna double check that the ROMs are in the right spot. 6 and 1, 6 and 1. And this is the character ROM 3, and that is good. I don't even have the VIC chip in here because that's what I was doing the testing with. So let's grab this one out of here. Known good VIC chip into the machine. Oop, a little buzzing going on there. Okay, here we go, power up. No, we have a machine that's still not working. All right, well, let's move on to this one. We'll get back to the video adjustments in a second. Let's just go right for the CPU here because, you know, maybe that's faulty as well. I was going to leave that there, and we'll take this one, which is the one I know works. Okay, here we go. Black screen still. Now, the problem is these two chips were bad, right? These two that have the blue dots on them. And notice this has got a bunch of other blue dot chips in here. So let's just pop these blue dot chips out of here. Maybe whatever these blue dot chips were in had catastrophic damage from the power supply or whatever. So that could be what's causing this machine not to work. So let's see if that changes anything. No, it doesn't. All right, well, what I'm going to do is I'm going to use the other motherboard there, and we're gonna test these chips. Okay, so I don't want to mix things up. So I know this is a good CPU here. Oh, that's so stuck in there. This chip puller is really good, but sometimes it doesn't work so great if the socket is really stiff. I really recommend you use something like this, which is a WeHad chip lifter. It's designed for pulling chips out of boards and doing it in a way that doesn't scratch up the motherboard or anything like that. I'm going to just pull out all these chips. Okay, these are out. Let's take these two ROM chips out. Let's just double check everything in the other board. Let's just rule out that any of those chips weren't bad, causing the machine to black screen. Oops, I actually just plugged this in while the computer was on. Luckily, that didn't seem to cause any damage. It just caused it to have the blue screen, you know, the cyan solid screen there. All right, there you go. Well, hot swappable VIC-2 chips. Yeah, this thing's working now. Okay, so let's try the CPU. I'm taking out the one I know is good here with the tick mark on it. And this is the one that was in the other board. Good, we have a nice working CPU. Now we have the two ROM chips here, basic and Kernel Rom. Okay, we're getting a black screen. One of these is bad. Let's see which one it is. First we'll take out the Kernel Rom. I am suspecting the Kernel Rom because remember, when we don't have a Kernel Rom, you really just get a black screen on a Vic-20. The Kernel Rom is needed to kind of initialize things. So let's see if that is the problem. Yes, it is. So we have a bad Kernel Rom here. So that gets an X. But we do have a working basic ROM, so that's good. Now, let's check out the character ROM. So this is the one that is obviously known good. And this is the blue dot one that came out of the other machine. Let's see if we got a working character ROM here. We do not. Wow. Okay, so there's a good example of what it looks like when you have a bad character ROM. On a Vic-20, you just get that. Let's pop this chip out entirely and see if that looks different, just so you can know what it looks like without a character ROM at all. Okay, you get shimmery shimmers. That's what I would expect. That's actually what happens on a 64, except you get it kind of all over the entire screen. It's interesting on the Vic-20, it only happens where there's letters. But we know for sure that chip is bad as well. Look at this, we have carnage going on here. Absolute carnage. So we're up to 5 bad chips here. So let's put the working character ROM back in. Oh, I almost bent the pin there. So there's the good one back in. Should have a working machine. Oh no, we don't. Wait, what happened? Oh wow, so maybe that chip's not bad. You know what? It would help if I put the chip in the right way. Maybe that's what happened with the other one. Maybe I falsely accused it of being bad. There's no notch on this chip. It just has the one spot right here, the circle. Okay, so that did not damage that chip. You know, you gotta be more careful. I need to be more careful. This one has a notch though. So I don't think I put this one in backwards, but let's just double check. Notches on the top on all the chips that are aligned this way on this board. And wow. That's giving us nothing at all. Oh, because that's not a character ROM chip. That is why. 46003, this is the character ROM chip that I did test. No bent pins, just double checking. The notches at the top, power on. Yeah, okay, that's what we saw when I had that one in backwards. But this is definitely not, the notch is aligned with all the rest of the chips. It's facing that direction. So this is the one I think works. There we go. There we go. It's looking good. All right. Next question. Are these two I/O chips bad? So let's pop these out of here. I think I can use this because I put Deoxit on there. I'm not totally sure that these work. So because I think they do, I mean, we know the keyboard started the game at least. So I'm going to put tick marks on these for now. But these blue ones, on the other hand, 6522 Schematics. Let's see if these are bad. We have a lot of blue dot carnage. Whatever the blue dot machine was. Lots of things wrong with it. Power on. Okay, we're getting a flashing cursor. That's a good sign that things are okay with this chip. Keyboard connected. Let's see if we got all the keys working. Yes, it does appear that the keyboard works. What I'm gonna do is, because I don't have a diagnostic harness, I'm just gonna swap these two chips around. They are the same. We're just gonna double check that they work in the opposite socket. Okay, notches are the right way. I don't see any bent pins. Power this on. Do we have a flashing cursor? We do. I have a feeling these chips are good. Let's see if we get a row of keys working. Yes, we do. I'd say everything is fine with those two chips. Okay, that's awesome news. Of course, 6522s, which is what these are still very easy to get. They're still common. It's not like the 6526s in the Vic or in the C64. Those are hard to find. These are actually pretty common still. Okay, so carnage so far. We have a Vic-2 chip. We have another Vic-2 chip. We have a 6502 with the blue dot. We have a character ROM with the blue dot. And we have a Kernel Rom that has no blue dot on it, a blue sticker, that is also bad. What we have here to put on the other board is a working basic ROM. We have a working CPU. We have the working I/O chips. And I'm gonna put these I/O chips back in this motherboard since this board appears to fully function. Let's swap out for the other board again. Try to make it work. Is the only thing wrong with this board simply that it had bad chips? Possibly. Let's deoxit those sockets. And again, I'm doing this mainly because it just makes putting the chips in easier. It's not like these sockets aren't corroded. I don't think there's going to be like a connection problem putting these ICs in here. It's more just, it's a pain if it's not deoxidated, because there's the lubricant in the deoxit, which really does help. It just helps avoid those bent pins. Okay, the two I/O chips, which again, we know are working, but they're not necessary for operation of the computer. It will turn on without them. Let's put in a working CPU here. Let's put in the working basic ROM here. It goes there. That's an extra CPU. These are all bad parts. Okay, I have another Kernel Rom here. We know this one works. And we're gonna have to go to the spare parts to grab the character generator. Here's one right here. Just double checking the notches are all up. They are. And we need another video chip. Here's one right here. I don't think I put Deoxit in there. Let's do that. Okay, there we are. Let's see if we have a working machine. Power is off. This machine's in pretty nice shape. Look how the shield here is not even corroded. Power on. Look at that. It works. It freaking works. Let's try Radar Rat Race in here so you can hear that bad music. We're gonna need the keyboard plugged in. Kind of shimmery, but that's just the way the video looks on some of these chips. All right, here we go. F1 to start. It's so bad. The music's like, it's totally not even in tune, the music. It's horrible. Absolutely horrible. Look, eek, he died. Okay, anyways. Oh, you know what? Let's try this other game here. Radon Fort Knox. Now, I mentioned that I had this Radar Rat Race when I was a kid. The funny thing is I don't think I had any other cartridge games. All the other games I had were cassette-based games. Now, I had a 16K RAM expansion cart, And that allowed me to play cassette games that were generally not, you know, wouldn't fit in the small amount of RAM. And I just waited very patiently for those games to load very slowly. Look at that, this game doesn't work. You know, I don't even know, I actually don't know, I never tested this cartridge. It just goes right to basic, which is weird. We saw this one have a little bit of an effect on the other one. Remember that other machine, it kind of went to a yellow screen for a little while. So let's get this out of here. Wow, let's put some Deoxit on this, which actually makes it go in and out of that cartridge connector much easier. Look at that. Oh, that was easy to put in. Oh, there it is, right on Fort Knox. Notice it had that yellow border on the boot screen, and then it went to this screen here, and that would be why it looked like it was just going to the normal cyan screen once it started. To move is P period, L, and semicolon, right? Or use a joystick. So let's try this. Whoa, this doesn't seem, oh, I see, there, I'm over there. Okay, I gotta turn this down. That sound is horrible. All right, well, the game's running. I think I'm supposed to grab this gold, if I recall, and then get it back to this, the entryway. That's what I recall is the way to play this game. Get to the $sign. There we go. It loaded, and I got to go and grab the other gold and avoid the baddie here. Whoops, which I didn't do. Okay, well, anyhow, we know Fort Knox is working. That needed a little Deoxit. I said it didn't need it in the sockets, but it's quite possible that the cartridge slot, which, wow, is easy to put in and out when it has Deoxit on it, that can be dirty and need it. Okay, so let's put tick marks on these things. We know that works. I'm gonna redraw a new tick mark there and there, so those are good. That's good, these are good, and that's good. Okay, so that's it. 2 working machines. Oh, I didn't talk about the video adjustment. Okay, I'm gonna grab the other one. So on older Vic-20s at least, if you plug in a composite monitor using a cable like this that I've made, you get a really dim picture. Now when I zoom in, you notice there's 2 adjustments. There's a pot right there, and then that's a variable capacitor. This one actually is adjusting or trimming this crystal oscillator here. So this has to do with the color clock. Now I'm gonna turn that just to show you what it does. Let me grab a little tool here, see if this one can do it. Here we go. Now when we watch the screen, notice the color is going all crazy. Really, you should never turn this one because it has to do with the color carrier. And obviously, we have a color picture. It's close enough, like the 3.54 megahertz or 3.597, whatever it is, the NTSC color clock. Just don't touch that one. But the pot, on the other hand, this one can be adjusted. And what it will do is it will dim the picture. So when I turn it down, okay, we lost the picture altogether. And that's because my retro tank obviously needs a sync signal that works. So turning this makes it get darker or brighter. See, look at that. Oh, you know what? I think there's actually Deoxit required for this because it looks like it's getting a little scratchy. Okay, there we go. So I think it was actually just losing connection. That's why it was going black altogether. But turn it back and forth a whole bunch. Okay, it's still doing it. A little more Deoxit required. Anyhow, long story short, this pot right here, it does adjust the video level. And if you turn on your Vic-20 with the cable and it looks like that, really dim and horrible, you need to adjust that pot. You need to turn up the video signal and make it where you turn it so it looks good like it does there. You don't want to turn it too much because that's like putting too much voltage. You want it to look good, like maybe that. Now, ideally, you should adjust this with an oscilloscope and actually look at the levels and everything. I'm not gonna do that. I'm just gonna kind of turn it where it looks good or the cyan is not totally blown out on the sides. So I'm gonna say that looks good, but that's the key. If you have a Vic-20 that's dim, you gotta turn that pot. And the other version of the motherboard has a similar pot, and that one always seems to be tuned out of the factory to be pretty dim. So there we have it, 2 working Vic-20s, and the only problem with them, and that's not one of the problems, was all of these bad chips right here. All right, there we have it, 5 bad chips for a Vic-20. People complain I don't put stuff in the dead parts bin. So there it is. All of those are in the dead parts bin, and you can see it's got lots of RAM in here. I've been using the RAM check lately, or RAM tester, that thing I have, to test my 72-pin and 32-pin memory. So I've had a lot of that, a lot of bad memory. So that's what's filling up this box. And to be honest, the other dead parts bin I have, which is a coffin, is also full of sims lately. But there are dip ICs in here, although I think that was one of the ones I just threw in there. So there it is, 5 bad chips for a Vic-20. And you know, what kind of has me worried is I wonder if this is the future of all of our retro computers. Are all these chips just gonna start going bad? Like, what happened to these 2 motherboards that resulted in so many bad chips? Did someone plug in a death power adapter that put 7 volts into it? I'm not sure, because I would have suspected that things like the RAM and some of those logic chips would be bad as well, and they weren't. Both of these machines just work. They just needed a few of those socketed chips replaced. So it kind of has me worried that down the road, maybe all the MOS chips are gonna die. And the problem with that is, for the most part, we can't replace all of those chips yet. I think a lot of them we can. Obviously, on a Vic-20, there are a lot more chips that can be replaced. The only thing that can't is the video chip, which maybe someone will make a replacement, FPGA replacement for it, video/sound chip. But on the 64, we already have modern replacements for the video chip and the SID chip. But what I'm not sure if we have a replacement for yet is the 6526 IO chips. Those are MOS parts that are only made from MOS for the 64, really. I think in one of the disk drives uses them as well. So that's worrisome. I mean, maybe someone can come up with a replacement for those as well. I'm sure that could happen. But it will be a sad day where our Commodore 64s need to have all modern replacement chips just to keep it working. I have old TTL logic chips from the 70s, like early 70s, that still work perfectly. So it's not like all chips are gonna die. It's just that these MOS chips from the 80s, they just don't seem super reliable. Anyhow, that's gonna be it. Brad, thanks very much for sending in these 2 Vic-20 boards. I hope people thought this repair was interesting. I'm gonna put that in quotes because in the end, all I did was swap chips around, so it's kind of lame. But at least on the first board, I was able to identify for sure that that CPU was indeed bad. And through process of elimination, determined that that video chip was definitely bad as well. So I went to my spares, and I'm glad to have those spares. So thank you to, I can't remember the name of the viewer who sent in all those spare chips, but someone else did as well. So very grateful to my viewers for supplying me with all these spare parts to keep these types of things working. So that's gonna be that. So if you liked this video, thumbs up. If you didn't, you know what to do. Huge thanks to my patrons. Their names are scrolling up the side of the screen. If you want to become a patron, you can do so at the link in the description below. I do want to mention that I have a merch store. I keep forgetting to show off the t-shirts. There's some t-shirts there, which look kind of cool with my logo on them and stuff like that. So you can check the link in the description if you want to order something from there. Comment down below. I think that's really it, right? So I guess that's it. So stay healthy, stay safe, and I'll see you next time. And next time it's gonna be back to the old Southwest Technical Products PC, the 6800 computer. We'll be working on that again. So see you later, or stay healthy, stay safe, and I'll see you next time. Bye. For real this time, bye.